All right, welcome to The Explainer. Today we are diving into something truly terrifying, one of the most powerful and, frankly, fearsome inventions in all of human history, the hydrogen bomb. So let's set the stage. It's 1945. The world gets its first shocking introduction to nuclear weapons. The atomic bombs dropped on Hiroshima and Nagasaki. They unleashed a force of about 20,000 tons of TNT. It was a terrifying new chapter for humanity, for sure. But get this, just a handful of years later, we created something 700 times more powerful. Can you even wrap your head around that? A single device with the force of 14 million tons of TNT. So how on earth is a leap like that even possible? Well, to figure that out, we've got to go back to the basics, to the core science. Okay, so to really get the H-bomb, we first have to talk about what makes it so different from its older cousin, the A-bomb. And that difference, it really all comes down to the science, right at the atomic level. It's about the huge difference between splitting an atom apart and smashing two atoms together. So here's the core of it. Your standard atomic bomb, that works by fission. You're splitting heavy atoms, like uranium, apart in this massive explosive chain reaction. But hydrogen bombs, they're a whole different ballgame. They use fusion, literally forcing light atoms like hydrogen to join together. So think about it. One is all about breaking things apart. The other is about building something new to release a ton of energy. Now, fission is obviously incredibly powerful, right? But it's got a built-in limit. You can only cram so much uranium into a device before it just becomes unstable on its own. There's a natural ceiling, a cap on how big you can make that explosion. Fusion, though, oh, that's different. It releases way more energy for every little reaction. This is literally the same process that powers our sun, and all the stars out there in the universe. And that means, in theory, there's no limit. The destructive power is practically infinite. And this is what it looks like. You've got two special types of hydrogen, deuterium and tritium, and when they fuse, they create helium, a spare neutron, and just a tremendous burst of pure energy. That's the engine of the H-bomb right there. So the billion-dollar question was, how do you create the insane heat and pressure of a star right here on Earth to kick this whole thing off? Well, the solution they came up with in 1951, it was absolutely brilliant. And at the same time, completely terrifying. This design changed everything. The idea is just mind-blowing, really. You take an entire atomic bomb and you don't use it as the main event. No, you use it as the trigger. It's like using a stick of dynamite to light the fuse on something 1,000 times bigger. And here it is, the famous Teller-Ulam design. It's a true two-stage weapon. So up top, in that smaller section, that's your primary. That's a regular old atomic bomb, your trigger. Then, down below in the bigger part, that's the secondary, and it's just packed with fusion fuel. Think about that. It is literally a bomb inside another bomb. And the whole thing goes off in a sequence of events that happens in a blink of an eye. Okay, you ready? Step 1, the primary A-bomb explodes. Step 2, a massive wave of X-rays from that blast instantly vaporizes a special foam filler, turning it into superheated plasma. Step 3, the pressure from that plasma is just unbelievable, and it crushes the secondary fusion fuel with unimaginable force. And finally, step 4, that intense heat and compression is enough to ignite the fusion reaction. And boom, a catastrophic star-like release of energy. It's a chain reaction on a cosmic scale, all happening in a split second. So yeah, this two-stage design, it didn't just make a bigger bomb. It completely redefined what a superweapon even was. It unlocked a level of destructive power that made the entire atomic age look, well, small. And the bombs themselves became just gigantic. Look at this. On one side, you've got the American Mark 17. It's literally the size of a small bus. And on the other, the Soviet Tsar Bomba, which was even bigger. Its yield was a staggering 50 megatons. That's 50 million tons of TNT. To put that in perspective, that's over 2,500 times more powerful than the bomb dropped on Hiroshima. And the very first time this idea was tested, the Ivy Mike test, it proved the concept worked, and it showed the world this terrifying new scale of power. What you're looking at right here, this is the moment humanity first bottled the power of a star, and then unleashed it right here on our own planet. Just look at these stats. The mushroom cloud shot into the stratosphere in less than 2 minutes.
It topped out at 37 kilometers high and eventually stretched out to be over 60 miles wide. All those numbers, all those diagrams we just looked at, this is when they became a horrifying, planet-altering reality.
You see, this technology, it wasn't just some abstract scientific breakthrough. It became the terrifying engine driving the Cold War arms race, and it would end up shaping global politics for decades to come. And this quote from the Soviet premier at the time, Nikita Khrushchev, wow, it just perfectly captures the grim, cold logic of the era. He said, "We're satisfied to be able to finish off the United States first time round. Once is quite enough." The goal wasn't about winning a war anymore. It was about ensuring the total annihilation of your enemy, a concept that got the very fitting name Mutual Assured Destruction, or MAD. So, in the end, the hydrogen bomb did more than just create a bigger explosion. It created an entirely new world. Suddenly, a huge conventional war between superpowers was basically impossible. It was replaced by a decades-long, tense Cold War, fought constantly under this nuclear shadow. And the question it forced humanity to ask back then, well, it's just as urgent today. Now that we know how to wield the power of a star, can we actually be trusted to control it?